Guys, in this video, we are going to talk about this problem, longest well-performing interval, Leetcode 1124. In this, we have been given hours or list of number of hours worked per day for a given employee. A day is considered to be a tiring day if the number of hours worked is strictly greater than 8. So if a person works more than 8 hours, the day will be called as tiring day. And a well-performing interval is interval of days for which the number of tiring days are strictly greater than the number of non-tiring days. You have to return the length of longest well-performing interval. So answer would be the length of the longest well-performing interval. So if this is the given array, you see like first day, like you can mark it as like tiring or non-tiring. So first will be tiring, and this is not tiring, and so on. Zero is also not tiring, and six is also not tiring, and last one is tiring, right? So this is how you can mark. Now what the sub array you want after out of this, you want to find a sub array in which the number of t is greater than number of nt. So if you see, this can be one of the valid subarray 996. The number of t are 2 and nt is 1. And you want it strictly greater. You cannot have equal as well. So not this. And this is the only possibility. So the answer for this would be 3, which is 996. This subarray. You don't have to return the subarray. You have to just return the size. So when you have to return the size um, of the sub array, or you can say it as window as well, like we say sometimes that range L2R we refer to as window. Why I'm saying this? Because this would look like a sliding window question, like based on the sliding window concept, in which we start our window at a particular point, let's say, and we keep on adding elements till the window is valid. For example, nt, this window is valid, this has 2t and 1nt. Now if you try to add one other element in this window, like if you try to take these four elements, double t double nt, right? So this is not valid because number of t's are equal, became equal. It should be strictly greater. So when you see a window becoming invalid, what we do in generally sliding approach, so we slide the window towards the right side, and we say that this element is now, let's say if these were the four elements, I cannot, yeah, like show it properly, but what we do is something like this, that okay, this element is now not included, and we are starting our window from this element to this element. But you see, if you do that, like, it would be good if this was nt, then we are removing some non-tiring day, but in this case we removed a tiring day. So we are like, this subarray is more, is not, yeah, better than the previous one. It's like, yeah, more worse than the previous one. So what we do, we again slide our window thinking that we will get a valid sub array afterwards, but now you cannot, like, nt, and then similarly you will reach a certain point that okay, I'm not taking any of the element in this, I'm just having this zero. This is also not tiring, so you cannot have this element as a single, yeah, single element also as a sub array. So then you start searching from the next window onwards. So you start a new window from this point, and you see, yeah, there is no point of making a window. It will be just, you will be just skipping elements, right? And then your next window, valid window, will be just this array. So there are the two valid window which you found, 996 and this 9, right? In this case it will work and it will give you answer as 3. But some cases, if I show you, if I just remove some of the elements from here, just these two elements, right? So if you see the given window, not the given, the complete array is also valid, but this will not be captured by sliding window technique. Let me show you how. So first of all, you will start your window at this particular point, you will end at this particular point. You see 996, and then afterwards taking one more element, you see that this is an invalid window, and you keep on sliding and moving your left point forward, 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 and you will skip all this, and then you will reach at this particular point that okay, now I have a single, so the two valid windows are still these, like 996 and this 9, but you have not captured this complete array as a window. Why did that happen? Because once you found the invalid window, you just shifted the right leftmost point, but you cannot bear with invalid window and take one more element, right? This is not the general standard sliding approach. That what we do, if we found the invalid element, let me not shift the left part to the right side, we can like just move the right forward. Okay, yeah, that's not a standard, but maybe you can implement that. But even if you implement that, that will be a very complex approach. So now let me let me talk about an observation that you should think for the tiring, non-tiring. Whenever you see something like this, less than 8, greater than 8, and based on that, some parity is changing, that it will become tiring or non-tiring, it will become positive or negative. So think in that terms of parity. So whenever you can convert this into binary array, that's what I'm saying, that if the value is greater than 8, consider this as 1, and if the value is less than 8, consider it as 0. But one thing I want to show you, that even if you do it as a binary 1 and 0, this will not be much helpful. Let me tell you how. So this is the thing. Now it like, how do you say that this 110 is valid and this 1100 is not valid, right? If you talk about sum, both have equal sum. This is also have sum equal to 2, this is also have sum equal to 2. But yeah, just the observation you can say here, that key number of 1 should be greater than number of 0 in a particular array. Now how will you find that? That is more or less same as that the number of elements greater than 8 and less than 8. So better thing we can do is, instead of 0, we can make it -1. So all the elements that are now it becomes really simple, and you may not go to the binary approach first. Just start thinking that, okay, tiring and non-tiring days, I want to make number of tiring days greater than number of non-tiring days. So if these are the number of plus ones and these are the number of -1, so overall sum should be positive, then we can say that this particular window is a valid window. If the particular sum is positive, after we are doing plus for something and we are reducing for something, right? Instead of keeping it 0 for non-tiring days, we are reducing that, because yeah, we want to reduce that because we want the total. In that case, it will be just easier to see that total sum positive. So now if you have converted this to this array where each element is converted to 1 or -1, if the element is greater than 8, you will write +1, right? If element is less than 8 or equal to 8, you will write -1. And then what you need to find out, you need to find out the longest subarray having positive sum. Now this problem is reduced to something like, which will look very standard, which will feel that, okay, that can be done very easily. Longest subarray having positive sum, you can write it as like that, positive sum, or sum greater than 0, right? Yeah. So this looks manageable, right? More manageable than the previous problem, like yeah, number of 8 should be greater than number of strictly elements strictly greater than 8 should be greater than number of elements smaller than 8. So but yeah, still we have to do this. How do we do this now? So we use a map. Yeah, how do we use a map? We try to, as we know that we have to see the sum, and we will say that a particular window is valid if the sum is positive. So this window is also valid, this single one is also valid, but the complete window is also valid again. But still you cannot apply the sliding window approach, right? So we use a map approach. So if we see 1, we just start our sum by 0, and then keep on like yeah, just make a prefix sum array. Forget it as a map, you can have it as pf sum, right? But why do we need a map? Because I'll tell you later. Because we need to find the particular point at which the sum occur. Okay, I'll show you what I'm saying, that okay, but first let's create a prefix some kind of thing. So 0 1 2, 2 minus 1 1, 1 minus 1 0, 1 plus 0 plus 1 1. So now every point where you see a positive number written in this final array, okay, positive means except from 0, okay, so there are three positions like 1 2 3. So what does this mean? That okay, starting from the leftmost point, which is just nothing, right? Like starting of the window till this particular index. So this 1, this 2, and this is also positive, this is also positive. So this particular pura thing and this pura thing is will obviously give you a positive sum. That's what the prefix sum says, that starting from the leftmost point till a current element, the sum, this is the sum. And if the sum is positive, we means that we say that okay, this window is a good window, right? This subarray is a good subarray, that number of tiring days are greater than number of non-tiring days. So whenever you see a positive sum, you capture that and you see the length of basically 0 to I. So if we see that in a particular, if the sum is positive, right? If the sum is positive, one of the possible option, your max will be update with uh, I plus 1, as simple as that. But what if when it is 0 or when it is negative? Because it can go negative, right? It can go negative, obviously. It will go -1, -2, and after that it can come positive as well. So it's not like, yeah, monotonic thing. It's changing its sign and order and everything. let's say there are again -1, so it become -3, but then it's going up, so it became -2 again, and it became -1 again, and then it became 0 again. Right, so this was -2, this was -1, this was 0, and this was 1, so it became positive again. So whenever you see positive, you know what to do. This is the maximum thing but you can take, like take everything till this point. Yeah, but when it is negative, you cannot say take everything at this point, because when you take everything till this point, you are getting a overall negative sum. That's what you do not want. You want a overall positive sum. So what is the minimum overall positive sum? That is 1, right? So let's, if you cannot make, some big, let's try to make even a smaller thing. So why I'm saying this is that if -1 is there occurring, this -1 can be happened by, you know if previous element was 0 and then I did -1, then you got to -1, right? Because the array contain only two type of element, +1 or -1. So it either it can be 0 -1 equal to -1, or -1, oh sorry, -2 plus 1 equal to -1. So there it is happening that -2 plus 1 करा तो -1 आया. ठीक है, तो for -1, if you are able to find any -2 index, okay, here you will find a -2 index. What does this mean? That this window started with the prefix of -2 and ended with the prefix of -1. It means the element within this range is giving me overall sum of +1. Then it is like -2 से -1 कैसे हुआ, क्योंकि बीच का जो sum है वो +1 है. ठीक है, and that's what you need to find out, man. Like for -1 अगर -3 भी लोगे तो that is more good. Like इसका जो overall window का sum है वो 2 होगा. But why this is not good in with our respect? Because इसका size जो होगा वो छोटा होगा. Because -3 अगर आया है, so there is no possibility that -3 can occur without occurrence of -2. We are saying that -3 can come with two options, कि -2 में -1 करा तो -3 आया, या फिर -3 में सॉरी -4 में +1 करा तो -3 आया. But -4, how this -4 came? Everything started with the 0. So 0 से ही start हुआ है, या तो वो 0 से ऊपर जाएगा या तो 0 से नीचे जाएगा. तो when it is going from 0 to downwards, so first you will see -1 first of all. Like -1 has to be the first negative element itself. -2 has to be the second negative element. It might be the case कि -1 के बाद 0 आया, फिर -1 आया, फिर 0 आया, फिर -1 आया. But -2 जब आएगा तो उससे पहले it cannot be any element which is like less than -2. -3 cannot occur before -2 in any scenario. Like here it is occurring, but I'm talking about the first occurrence. Okay, that's why we need the first occurrence, because we want to maximize the window size. So -1 के लिए मैं -2 तो देखूंगा, but ये वाला -2 नहीं, ये वाला -2 देखूंगा, because that will give me the maximum size obviously. And sum तो सेम ही है दोनों विंडो का, कि इस विंडो का भी सम 1 है, इस विंडो का भी सम 1 है. So this was the approach, man. Like now let me code it up. First of all, I'll create a updated array. I'll call it updated array of size n for I can say that or maybe like this only, I is equal to 0 till I, let's, and I plus plus for each element. Basically, if your element a of I, sorry, hours of I is greater than 8, I'll say that okay, up array equal to, or you can also write that up array of I is equal to um, hours of I, like if uh, of I is greater than 8, then 1, else -1, something like this. Okay, so this will give you this up array, updated array. Sorry, this is not up array, this is updated array. And then why do you need map? Because we will ask that okay, the positive के case में it's very simple, that you are getting I plus 1, but for negative -1 के लिए I will ask when does the -2 first occurred. So इसको कैसे स्टोर करेंगे, इसको मैप में स्टोर कर सकते हैं वेरी इजीली. फॉर एंड प्रीफिक्स हम तो हमें चाहिए ही. What I'll do that, okay, for int I is equal to 0 is less than, if current sum, and what I'll do that current sum plus equal to updated array of I, and if this current sum is already present in map. Okay, first of all, if current sum is positive, then your max will be updated with max of I plus 1, right? And I'll have a max variable over here like answer. Hmm. Else if it is negative, mm, actually you don't even need to put the positive elements into the map. You just need to put wherever this the negative sum, because only -1 will be asking for something like 0, you know. Okay, तो 0 को भी put कर देते हैं, ठीक है, because 1 will not be asking for anything, ठीक है. -1 will be asking for even if it is -1, you know, you can just say my I plus 1, because we know that this is the thing, like yeah. But still what we can easily do is that या फिर we can say अगर अगर करंट सम कहीं पे -1 भी है, so it is greater than -2, तो मैं ये बोल सकता हूँ max of I plus 1, because अगर वो -1 भी है, no no no, for -1 you are searching for -2, sorry, yeah, it has to be positive. For -1 you will be searching for -2. So you see that if map dot find, right, of the current sum, right, is not equal to map dot end, means it is present, ठीक है. एक तो ये चीज है कि मेरे को इंसर्ट भी करना है, ठीक है, तो इंसर्ट पहले करें या बाद में करें, कभी कर दो, वैसे उससे फर्क नहीं पड़ता कि इंसर्ट इफ इट इज नॉट प्रेजेंट देन मैप ऑफ करंट सम इक्वल टू आई, ठीक है. बट मेन मेरे को क्या चाहिए कि इफ मैप डॉट फाइंड करंट सम -1 कहाँ पे आया हुआ है, अगर आया हुआ है तो इफ नॉट इक्वल टू m डॉट एंड, सो -1 के लिए आई विल बी फाइंडिंग कि -2 आ रखा है कि नहीं आ रखा, नहीं आ रखा, ठीक है, कोई इशू नहीं है. अगर नहीं आ रखा तो इसके अंदर, इफ के अंदर नहीं जाएगा, ठीक है. और ये इफ के अंदर कब जाएगा, जब ये -2 के लिए -3 पूछ रहा होगा, तो ये मेरे को दे देगा. जब -1 के लिए -2 पूछ रहा होगा, तो ये वाला -2 मेरे को मिलेगा, राइट. अगर इफ दिस इज अकर्ड तो वो कौन से इंडेक्स पे आया था, तो मैक्स से अपडेट होगा, मैक्स ऑफ करंट इंडेक्स जिस पे तुम खड़े हो, एंड मैप ऑफ करंट सम -1, ठीक है. बिकॉज जनरली हम जब दो इंडेक्स को माइनस करते हैं तो हम +1 करते हैं, बिकॉज वी से दैट कि 0 to 3 का डिस्टेंस 4 होता है, ठीक है, राइट. कि दिस इज द 0th index and this is 1 index, this is 2 index and 3 index, so between 3 2 and 0 there are 4 elements. बट यहाँ पे वैसा सीन नहीं है, क्योंकि -1 और -2, what I'm taking, am I taking all these 4 elements? No, I'm taking these last 3 element, तो इसलिए मैं +1 नहीं करूँगा, because I'm not taking this -2 in me, I'm just taking this these 4 elements, ठीक. So I think that is fine, and we can return maximum. Let us comment this up, run code, and if it is I think it should work. Updated n is not defined, n is not defined. urs dot size, and now updated array should be fine, and based on that m of 0 You can put, but who will ask for 0? One will ask for 0. Why do we even need to ask for 0? No, it's he don't need to ask for 0, right? So let's see. Let's just submit it up. It should pass. 669. What is an issue in this? 0. It's 1. K. It's -1, and then this is -2, and then this is -1. ठीक है, तो if current sum is negative है, ठीक है, current sum plus equal to updated array of I, it is negative. ये तो नहीं मिला इसे, but if, oh sorry, if equal to m dot n, then हमें करना है ये push इसमें, otherwise what is the need? Yeah, ठीक है. So okay guys, that's about it. Bye.